A very good morning to everyone present over here. Myself, Jafar Sadiq Ali, working as a professor in the Department of Electrical and Electronics Engineering of Sri Muthukumar Institute of Technology, Chennai. As part of this IoT concept applications series of lectures, today we are going to cover the last two topics of in Unit 2, that is GPS and GSM. Let's go through this. This is a course objective. Again, first Unit 2 is to analyze various communication protocols as well as models for cost-effective design of IoT applications on different IoT platforms. It's to understand the communication models as well as various protocols for IoT applications. Okay, in this GPS, what is GPS? We all know global positioning systems, mainly used in to nowadays everyone is using this facility GPS. Yes, we are having the location in our WhatsApp also. So as you move on, it will keep on again moving. How it is moving? Your location is keenly watched by the satellite communication. So through which you are able to track things. Even if you go, if a chip is being embedded into your body, then wherever you go in the world, your entire thing will be tracked, movement will be tracked. So likewise, if you have the courier parcel to overseas countries means exactly you can able to identify in which longitude and latitude currently your parcel has been traveling into it. So that much technology we have been developed using the help of GPS systems. So global positioning systems is a satellite based navigation systems that provides location, that means longitude and latitude and timings as well as velocity information anywhere on Earth, developed and maintained by the United States Space Force. It consists of around 30 satellites orbiting the Earth. It works using the principle of trilateration. A GPS receiver calculates its position by measuring the time taken for signals from multiple satellites to reach it. And the segments of GPSs, you have space segment, control segment, user segment. Space segment is nothing but the machineries that are in the orbit, that is satellite. Control segment means the ground stations, ground control stations. On the Earth, some control mechanisms has been there to control and monitor everything. The last one is user segment, that is GPS receiver antenna. That's in the mobile or in car or whatever it may be. So let's see the one by one. This is the GPS space segment, control segment, and user segment. User segment can be anything, a man or any device, mobile device, a ship, car, van, truck, airplane, whatever it may be, all are called as a user segment. Space segment is nothing but the satellite through which we are able to send the information and receive the informations. And control segments, we have monitoring stations and also ground antennas through which we are receiving the informations, and also a master control stations also is available to control the entire operation of the systems, CP systems. So range is worldwide. So range is worldwide. The satellite is sitting on top of our orbit, Earth orbit, and for civilian and for military purposes, everything accuracy is varies. So GPS works anywhere with a clear view of the sky. So usage of GPS is finding locations, navigations as well as the route guidance, and speed calculations as well as the time synchronizations. For these purposes, as we have GPS usage and various applications right from transportations, that is car navigations, fleet net tracking, traffic monitoring, aviation and marine, aircraft ship to positioning, smartphones, we are using Google Maps and ride sharing maps also. Yes, we have. Every day we have Ola, Uber, Rapido, all those things, and agriculture. It's used for precision farming as well as tractor automations. And last one is surveying and mapping for land measurement as well as geographic information systems. All the there are it's endless applications are that we are limited to only 5 different areas. And the advantages is it's global coverage, free civilian access, is it's free of cost, it's high accuracy, and it's available for 24/7. The main disadvantage is that it requires clear sky view, signal sometimes blockage happens due to in the in if you are in the indoors or in the grounds areas, basement areas, and susceptible to interference. Some disturbance may happen for this. So these are all about GPS systems. And next we are mainly talk about this GSM module. What is GSM? Global System for Mobile Communication. GSM is a 2G digital cellular communication system used for mobile voice as well as data services. See, it's basically used only mainly for mobile voice over as well as data services only we are using for GSM module. It's developed by the European Telecommunications Standard Institute. It mainly operates in the frequency 900 megahertz, 1800 megahertz, these two only. And apart from this, the specific applications are there for 850 megahertz as well as 1900 megahertz bands. It uses TDMA, that's time division multiple access technique only. And GSM is the main foundation for all the modern mobile communication systems. It supports, as we said earlier, voice as well as SMS and packet data services through technologies such as GPRS and edge services. Mainly in our IoT systems, GSM modules is called as a SIM 800 or SIM 900. That's currently available in the market. Enable devices to communicate with remote servers using AT commands over UART interfaces. So if you take this software and if you open the software of and if you look for the GSM module means SIM 800 or SIM 900 version is available currently in the market as well as the simulation tool also, Proteus tool also. So it communicates with the outside world through the UART, Universal Asynchronous, okay, uh, interface only it uses. Data transmission typically occurs via SMS or TCP/IP over GPR system, making GSM suitable for applications such as smart metering, remote monitoring, vehicle tracking, and industrial automations. One of the major disadvantages is that no, it has a very high power consumption. And one of the very good advantages is that it can be either rural or urban, anywhere in the world, it can be easily accessible. That's the main advantage. And also at the same time, it has a big disadvantage is that it has high power consumptions. But whatever it may be, GSM remains a reliable, practical solution for many embedded IoT systems requiring moderate data rates as well as long distance communications. GSM. This GSM architecture, if you see from left hand side, you use a mobile phone, and mobile phone will have the handset, you have the SIM card, SIM identification, yeah, separate number. Okay, then Through this, we insert the SIM into our mobile phone. It is going to have the say receive the and send the data through this cell transmitter and receiver. It's called as a BTS, base trans receiver station. So the trans receiver station only is the main backbone of all the cellular communications. And apart from this base transceiver station, you have base station controller (BSC). It controls many BTS. BSC controls many BTS stations. And also there is one called BSS, base station subsystem. It consists of both whatever we have seen BTS as well as BSC, base transceiver station, and also base station controller. Both comprises called as a base station subsystems. And on top of this MSC, mobile switching center, we have wherein all the base stations and base station controller are connected together and forming a bigger picture mobile switching center. And everything has to gone through a common gateway channel, gateway MSC, mobile switching center. See in this figure, all the BSCs and BTs are interconnected together, and it is being connected to the MSC gateway MSC. And from there on, it will be given connection to the end user of landline users, interface to LAN telephone networks, PSTN or ISDN or PDN or whatever it may be. So this again MSC consists of getting information from right from EIR, Equipment Identifier Register, and VLR, Visitor Location Register, and HLR, Home Location Register, and also the last one is AUC, Authentication Center. So everything is consists of comes under GSM architecture. This whole architecture works. If any one fails, no, then the entire thing will be collapsed. So we need to be cautiously monitor each and every workstation. So that's why we have seen main components MS, BTS, BSC, and MSC. And applications as we all know that advantages is wide coverage area, and main disadvantage is that it's low data speed, and nowadays it is being replaced by our 3G, 4G, and 5G network. Okay, and it has main disadvantage that it has very limited multimedia capacity GSM. So now everything is being getting replaced. Okay, we are able to send any amount of data throughout the world. And this is what the references which I have referred, textbooks as well as reference books. Thank you.